Hey everyone, welcome to converting a point from rectangular to polar coordinates. Okay, so the idea here is we're going to be taking a point that's written as xy and converting it to r comma theta, the radius comma the angle, which is in degrees or radians. So the three things that we're going to use today are we're going to plot our point xy, and then we're going to find our r value by looking at the distance formula, r being the square root of x squared plus y squared, and then we can find theta by using tan theta is equal to y over x. So these three things are going to help us to convert from rectangular to polar form. Alright, so let's look at our first example. So example number 1. Find the polar coordinates of the point whose rectangular coordinates are 1, negative 3, and b, negative 2, 0. So a couple things we can think about if we rewrite this 1, negative root 3. Okay, we know this is x and this is y. So we can quickly find our r value. So r is equal to this square root of x squared plus y squared. Now I'm going a little bit out of order, and that's okay. So you don't have to follow those same steps in order. So I get 1 squared plus negative root 3 squared. Okay, and now we're going to have the square root of 1 plus 3, which is 1 plus 3 is 4, so you get the square root of 4, which equals 2. So our r value is going to be 2. Now I can go ahead and plot this if I want to. Okay, so I'm going to make a bigger graph, and it doesn't matter really for accuracy, at least in my opinion it doesn't. Okay, it only matters which quadrant you're in. So we're going 1 over and negative root 3 down, so it's going to be in the fourth quadrant. So I can go ahead and draw this a little bit larger so you can see, because I want theta to be here. Okay, this length is 1, this is negative root 3. Okay, so now we just have to find our angle. Okay, and now we can come up here and we can think about tangent of theta being equal to negative root 3 over 1, okay, which is tan theta is equal to negative root 3. Now, if I'm thinking about the unit circle, okay, if I go ahead and draw this, at 60 degrees, okay, we have a tangent of pi over 3 equaling root 3. Now, I need a negative root 3, so that means either sine or cosine has to be negative, okay? That just has to be. So we have pi over 3 here, and now if we want 2 pi over, pi over 3, we can find where we get a negative angle in the second quadrant, so over here, okay? We can get that, okay? And we can do that by taking pi minus pi over 3, which equals 2 pi over 3, okay? So when we look at what angle gives us a negative root 3 value, it is going to be 2 pi over 3, which is this angle right here. So our answer for part A is going to be 2 pi over 3. That is the polar form of the point 1, negative root 3. Okay, so let's go ahead now, let's go back and look at our second example. Now our second example is the point negative 2, 0. Okay, so this one's a little bit easier. Now this one I'm going to switch up. I'm going to go ahead and draw this first. Okay, so I'm going to go ahead and draw this. Okay, negative 2, 0 is really easy for me to plot. I'm going to plot it in red. And now this is one where, since I have a y-coordinate, in this case of 0, I don't actually have to do any of the arithmetic I did in the last example. R is a distance from the origin to the point, so here to here, that's 2. Theta is that angle representation, which is from here to the terminal side here, boom, which is just pi. So I know that the point negative 2, 0 in polar form is going to be equal to 2, pi. Okay? So those are just two examples of how to convert from rectangular to polar coordinates. So if you have any questions or comments, type them below. We'll see you next time.